Hello everyone, welcome back to vishnusmartinfo channel. I hope you all are doing great and doing your physics great, getting good scores in your exams and your preparation is going well for your dream college. So now let's begin with today's lecture. So I am your track 2 physics mentor this side charusharma, and I'm really sorry for getting late for the third lecture of mechanical properties of fluids, because suddenly I had cough, and because of the cough my throat was really weak. I couldn't speak anything properly, so I did take 2 days rest, and now today here is the video, the lecture 3 for mechanical properties of fluids. So I hope you will like this video. So in the last lecture we have discussed on barometer, okay, and in manometer, all these applications we have discussed. So today's lecture will be completely about the pressure. So pressure, how in different ways the questions will be asked, all the applications I will say, and also in today's video we are going to discuss like related to all topics which are related to Pascal's law. Okay, so let's start with the first thing. Let me just make you recollect what is pressure. Pressure was nothing but force upon area, and already this question has been asked in the previous video, but I didn't find any correct answers for it. So now I want an answer for this question again, that force is vector, area is vector, then what is pressure? Is it vector or is it scalar? I want this answer, please, in the comment box below. And here force you should consider, I already said you, normal force. If you don't know what is the normal force, just slide your hands to the previous videos and you will get the answer what is normal force. Okay, so now let's move on to the next topic of today's first topic of class, that is pressure difference between 2 points of a liquid. So what is the pressure difference? How you calculate pressure difference? I already said you that in barometer, how do you find pressure difference? So pressure is equals to P naught at a particular point plus H dg. So H is the height difference between this point and this point, then D is the density and G is the acceleration due to gravity. So I hope you know this. So how do you find pressure difference between 2 points? Is suppose you have a beaker like this, and in this fluid is filled on, okay, and here you will have the atmospheric pressure, that is P naught, because this area of the fluid is in contact with the air. And suppose let me mark this point as P1 and let me mark this point as P2, and the difference of height between these 2 points are H. So for so how can I write P1 can I write as P naught plus, okay, let me understand like this. The height difference between P naught and P1 is H1, and the height difference between P naught and P2 is H2. Okay, is that clear? So how can I write P1 pressure? P1 pressure is equals to P naught plus H1 dg. Similarly P2 pressure is P naught plus H2 dg. Yes, easy. Now I said you pressure difference. What is pressure difference here? Pressure difference is nothing but P1 minus P2. So that is nothing but P naught plus H1 dg minus P naught plus H2 dg. So P naught gets cancelled. It is nothing but H1 dg minus H2 dg. So can I write this as H1 minus H2 and dg taken common? Now we know what is H1 minus H2. This height minus this height will nothing but the difference between the points. This is, let us consider height to be H. So that is nothing but HdG. So HdG is nothing but the difference of pressure between those 2 points. I will explain once again pressure difference, how to calculate. First of all, mark your 2 points and mark the height difference from the P0 point to that particular point. So the difference of height between P1 and P0 is H1. The difference of height between P2 and P0 is H2. then you should say that P1 is equals to P0 plus H1 dg. Then you should say P2 is equals to P0 plus H2 dg. Now pressure difference means nothing but P1 minus P2. So you do P1 minus P2 and you write the equations again here. So P0 gets cancelled. Again you will get H1 dg minus H2 dg. Then you can take dg common out and H1 minus H2 or H2 minus H1. Anything where the point locates, it depends upon that particular thing. Okay, easy. Now in this question I have wantedly did something wrong. I want you all to notice that what is that particular wrong thing. Okay, I want the answers right now in the chat box. Like one simple concept I did wrong. I already told you in my previous video that pressure at that particular point is equal to pressure of initial atmospheric pressure plus HdG, right? That means what? That particular point ka pressure is more by this much height. So can't you see this common relation? See, P2 is more below than the P1 point, right? So for P2 the height is more. If height is more, P2 pressure should be more, no? So how can I do P1 minus P2? I should do P2 minus P1. Understood? I wantedly did this thing first step wrong because you should remember that no, we should not do P1 minus P2. It's not just P1 or P2. It depends upon the point. So here you can see the point P2 point is at more height difference as compared to P1. So the pressure see now this value same for both. What is changing is height only. Now again dg also same. Now H1 value is more, H2 value is more, H2 value is more. So H2 value is more means P2 pressure should be more, no? So if P2 pressure is more, then you should do P1 minus P2 or P2 minus P1. Okay, so from this thing I want you to make you understand that how much the point below or more the depth is, more the pressure is. Obviously, now if you go more below of the water, you will start feeling more pressure on yourself. Okay, so here what you should do P2 minus P1. So you will get here answer as H2 minus H1 common dg. The same method again. So as this question, as height is more, H2 is greater than H1. That's why pressure P2 is greater than P1. Okay. Understood? Means more the depth, more is the pressure. Remember this concept. Just don't simply or blindly go P1 minus P2. For you to understand this thing, I have done that simple thing wrong. Okay. So now let's move on to the same question, same concept. Now the vessel was at rest, right? Now what we will do is we will make the vessel to move. We will make the vessel to move. So the first thing is vessel in accelerating. Vessel is accelerating. So vessel can accelerate either upwards or either decelerate downwards. Both mean same. Vessel is accelerating upwards if I say. Okay, means what? Your vessel is going like this up and fastly it's going up. Or same thing I can say vessel is decelerating downwards, means the acceleration towards down is decreasing. It is going up means obviously acceleration toward down is decreasing, no? So I can also say decelerating downwards. The same application. Oh, I'm sorry. I just clicked on the screen. Okay, fine. So vessel is accelerating upwards or decelerating downwards. So what here you need to do, see whatever the pressure difference we were calculating. Can I write pressure difference as delta P? And we took H common. We took so whatever the height we are taking H2 minus H1. Instead of taking again and again H2 minus H1, I am writing that different height difference simply by H and D. Now here we used to write G, right? Just simply G. But now as the vessel has some acceleration, vessel has some acceleration with it. Some acceleration is there. So here with gravitational acceleration, you should consider this particular acceleration also. Now as here this acceleration is there, it's not a deceleration, it's a acceleration towards upward direction. I am considering to be getting added. So it is G plus A. Okay, that's it. Similarly, if the same application was asked as some color, oh my god. Okay, if the same application is asked as vessel is decelerating. Vessel is decelerating. No, vessel is accelerating downwards. Accelerating downwards. If this was the question, means it is coming down. So this is your vessel, it is coming downwards like this. So what will be the pressure difference? Then you should remember delta P is equals to height difference into density into here G minus A. Okay, easy, understood? So whenever it is accelerating downwards, put G minus A, accelerating upwards G plus A. The same accelerating upwards, they may give one more point here as for accelerating upwards, they can also say, where should I write? Okay, for accelerating upwards, they can also say decelerating downwards. Decelerating, going up, no, you just find out it is finally going up or coming down. So decelerating downward means the acceleration towards down direction is decreasing. What does that mean? That it is going up. So just by reading the question sentence, you should just figure out, is it coming down or is it going up? So if it is coming up, if it is going up, it is going up. If this is the final conclusion, diagrammatic conclusion that the vessel was going up, then this should be your formula used. That change in pressure is equal to H into density into G plus A. Acceleration should be added. And if it is coming down, if finally you figure out that the vessel was coming down, then it should be G minus A. I hope that was very clear. I made it very clear. Okay. Okay. So let's move on to the next topic here. So the same, what I said today, we'll completely discuss on pressure. So all the pressure related concepts I'm clearing off. The next topic today is vessel moving with uniform velocity. Vessel is having uniform velocity. Vessel with uniform velocity. If this is the condition, then remember what you should do. No acceleration means directly your formula remains as simple as that. No acceleration, so nothing to add, nothing to go, because uniform velocity mein acceleration is 0. Okay, that's it. Now suppose vessel was going in horizontal direction. This was in the terms like when it is moving up and down. But now if we consider vessel accelerating in horizontal direction. Okay, if this is the case, this is directly I'm giving. You will find directly questions like this. I am not explain what I say. The lecture is I am not taking it unnecessary way. I am just telling you the simple direct concepts. You will see this direct questions in your exam. This direct questions, I can guarantee that. Okay. There is no use of learning extra concepts. Just do your work. अपना काम करके निकल जाओ. आपका काम क्या है? पढ़ना. फिजिक्स कैसे भी पढ़ो, डायरेक्ट सिंपल कॉन्सेप्ट्स पढ़ो या फिर फालतू की चीज़ें पढ़ो. तो हम सिंपल कॉन्सेप्ट्स पढ़ के स्मार्ट बच्चों की तरह फटाफट अपना काम करके निकल जाएंगे. ओके, फाइन. So for example, if I say that the vessel was accelerating in horizontal direction like this. So automatically if you move the vessel like this, in this direction, if you move, your water level will become like this, right? You try to move a glass of water. You take your water glass in whatever you drink water and try to move like this horizontally. You will see the water level was not remaining like this same, but it became slant. Okay. So just do it right now. Pause the video, go and get some glass of water and drink it. First you do this thing and then drink that amount of water. Good for your health also. So your water became like this slant. Okay. So now what I will do is, so this was your initial, like your water was first in this point, right? Initial point. Now it became this much height increased. So let me consider this height to be small h. Now let me take this point as P1 and this point as P2. So according to our concept, what we will think, that both are at the same horizontal level, pressure is same. P1 is equals to P2. That only will think now. Wrong. What I said, same horizontal level with respect to the surface. See, for this part, how much is the height difference? The height difference is h2 anko. And for this part, P1, height difference is how much? For this part, height difference is how much? h1, no? See, you can say directly h1 is greater than h2. Then how can P1 and P2 be equal? If height is more, I said you pressure should be more, means P1 is greater than P2. And what is the difference between h1 and h2? It is nothing but this h height. How much slant area, how much slant height is increased. And let me consider this difference between them. Distance between P1 and P2, let be L length. Okay. So now if I want to find the net force, what is the net force means? See, here some force will be applied by the liquid like this, and here some normal to the area I said, right? So you have to consider here a cylindrical cross-sectional area. For example, I am considering this to be a cylinder over here. So for this surface of the cylinder, okay, for this surface of the cylinder like this, normal force will be like this. So how do you calculate force? Pressure is equals to force upon area. So force is equals to pressure into area, right? So for this part, let me consider this point as first point and let me consider this as the second point. So tell me the force for the first point. What was the force for the first point? Then F1 is equals to P1 into A, because area remains same for both. For here F2, net force is equals to P2 into A, pressure into A. Pressure is different, I said you. So what will be the net force? Now you know that which is greater. I already said you which pressure is greater. P1 is greater, then F1 is also greater. So F net will be F1 minus F2. Yes. So F net is F1 minus F2 means P1 into A minus P2 into A. So P1 minus P2 taken, area taken common. You know that force can be written into mass into acceleration. Now acceleration is nothing but the acceleration of this vessel, right? So acceleration. Now can I write mass density is equals to, can I take here density is equals to mass upon volume. So mass is equals to density into volume. Can I write volume as density into volume as area into length? Now what is the area? A, cross section area A, and what is the L? This is the L height. This is the L height, right? This is the L height. Okay. So here this is equals to mass. So just substitute this thing here. So what you will get? And one more thing I want you to know, that like this though I am explaining on the screen. So do you want me to share this on Telegram or not? Like this as a daily notes, you want me to share it on Telegram or not? Let me know in the comment section below. Okay, so area into, so what I am saying, mass, can I write density, area, length into acceleration, which is equals to P1 minus P2 into A. So A gets cancelled. So your DLA is equals to P1 minus P2. So here also you will get similar, like how you used to get pressure is equals to, change in pressure is equals to HdG. Here instead of H, you are getting the height difference between 2 points. Whatever H it is height difference between 2 points. So what is the difference between 2 points? Is this only, no? Is this part only the difference, right? Or not? So that is the difference. Density as it is, acceleration it is horizontal direction. So you will consider acceleration of horizontal. There is no role of gravity here. Okay, P1 minus P2. But for P1 minus P2, can I write this P1 in terms of height also? See from this part, that arey, what happened? Where did my vessel go? Okay, so for this, From this, can I write P1 is equals to H1 dg? Yes, because pressure is equals to P naught plus like that, no? So in that terms also I can write P1 and P2, right? So I am writing like that only. P1 is equals to P naught plus H1 dg, and for P2 again I am writing P naught plus H2 dg. Again here P1 minus P2, substitute these equations here. So what you will get, dLA. What is D? Density. L is the difference between 2 points. A is the acceleration. Is equals to P1. You can write P naught plus H1 dg minus this term P1 term minus P2. So in P2 you should write this part. So P naught plus H2 dg. Okay, so P naught again gets cancelled. What you will get, dLA is equals to H1 minus H2 dg, right? Arey yaar, H1 minus dg. So density gets cancelled. So what you will get, LA is equals to H1 minus H2 into G. Okay. So H1 minus H2. If you consider this triangle over here, again, this triangle part, is this not L? Okay. And this H1 minus H2 is nothing but your H only, no? I said you here. So this part, this H part, this part of the triangle, like this it is, no? So I will make this triangle down here again for you all. So like this is the triangle. So this is H1 minus H2 here. This part, not H1 minus H2. This is L. This is L length, right? And this is your H. This H is nothing but equal to H1 minus H2. So can I write this theta? Tan theta is equals to H1 minus H2 divided upon L. And acceleration is in this direction, gravity is in this direction. Again I can make a triangle for this also. Acceleration here, gravity here, join this. So what your theta again here becomes, tan theta is also equal to A by G. Okay, this to from your third chapter, Newton's law of motions. In that chapter you will learn a pseudo force. May you make like this triangle. So these both are equal. So H1 minus H2 upon L is equals to A by G is equal to tan theta. So this is your final derivation. Okay. So I hope it's very clear. So just in this topic, several questions can be asked. Vessel, in the application of vessel accelerating in horizontal direction, diagrammatic question can be asked. Which pressure is more can be asked. Then they can ask what is the net force they can ask. Then they can ask you the value of acceleration from these values. Then if possible they can ask you the value of tan theta. So how do you calculate tan theta? I already explained you. So I've explained you from very basic concept. Okay. Clear everything? Easy peasy lemon squeezy. So I have made everything clear in this video. So now we are done, I guess. Just a small concept of pressure, then we are done with pressure. Next video will be on Archimedes principle. Okay, and I hope in 9th and 10th the smaller classes you have learnt about Pascal law, that it is used in hydraulic brakes and how it is used. Like what is Pascal law is, whatever the pressure in that particular area it is, that same pressure will be transferred to all the points of that particular fluid. Okay, so that is nothing but your Pascal law, which is used in hydraulic principle. You know what is hydraulic principle, right? Next, so if this is your vessel, okay, if you don't know and you want me to detailedly explain on hydraulic principle, just let me know that in the comment box below, so that I can make a separate video on that particular topic. Okay, suppose now one question I am giving, that's it, and with this we'll end this class today. So this is your box. Again my throat is getting bad. Okay, so this is PA, point PA, this is a point PC, this is a point PB, and this is a point PD. This is a question for you all. Okay, the difference here is L1, the height difference is H2, the height difference is H1, and this difference is L2. I hope the points are very clear. Let me mark the points with some other color. Point A, point C, point D, point B. Easy peasy. Now I want you to let me know what is the pressure at A, what is the pressure value at C, PC. Okay. What is the pressure value at PC? I will give you a hint again. What is the pressure value at PA minus PC? What is the pressure difference? Okay, I am also saying that this vessel is moving in this direction with acceleration A. Okay, so I want this pressure difference. Then I want PB ka value. I want PD ka value. I want PD minus PB ka value. I have already given you a hint that pressure A is greater than pressure C. Okay. Sorry. Yeah, that is correct. So one more thing I want you to know. So these three, how many questions? 1, 2, 3, 4, 5, 6. So just type all this thing and send in just one comment. All the 6 questions ka answer. And also the first question, pressure is scalar or vector. Okay, so please send this answer. I won't see whatever the questions I will ask, until you people answer in the comment box, I won't reveal the correct answers. So till now, for so many questions people haven't answered. So even you have not got the real answers or what is the correct answer for that particular question. So that is your loss. Okay, if you don't comment, it is your loss, because if suddenly this question only comes in neat and then you regret that, oh, if we have commented correctly on that video and then we have got the correct answer, it would be great. So if you message your answer, if you comment your answer, only you will come to know the correct answer, and no one knows which question can drop in the exam. Okay, so the hint over here is, I will not explain the hint also. The simple hint is pressure at A point is 0. Very simple hint. Okay, even pressure, one more hint I am giving, pressure at C point is also equal to 0. Why? The answer of this why is in the first lecture of the class. Okay, so if you want to know the why ka answer, that is in first lecture, even also mentioned in the second lecture of mechanical properties of fluids. So PA and PC is equals to 0. I am telling you that hint. Now I want all the 6 questions ka answer in the comment box below to whatever related I have taught you today. Okay, and I also gave you hint that a vessel is accelerating in horizontal direction. Okay, that's easy for today. That's it for today. I hope you all are doing good. Do great in your preparation. Don't become lazy. Your parents are spending a lot of time and money on you. Just give justice to it and get into medical college and get your own stethoscope for yourself. That's all my prayers for you. Thank you very much. Have a good day and be regular to the classes. And also I'm going to reveal whatever the plan is coming in December month. That plan revealing also will be done after this chapter gets over. Okay, so be regular to the classes. I hope you will be, and do your great. And please do comment the feedbacks also. If you want me to improve in certain way, just comment your feedbacks also, and also please comment the answers. No baba, please. Thank you very much. Bye. Take care. Like and share and subscribe the channel to your friends and help the people how much ever you want, because it's just free of cost. It's not taking a penny of money of you. Okay then, bye, take care, tata.